In our next GibbsCAM video, GibbsCAM version 2023, we're going to show you enhancements 9 through 12. So let's get started. The first one's going to be extended drill cycles holes. So for this, we have, let's bring up a part here. As you can see, I have a number of holes in this part. So in this first segment, we have drill, feed in, wrap it out, of course. This is just going to be our spot drill to spot the holes. The next one is going to be variable feed, peck, full out. So on here I have, of course, my RPM, feed rate, whatever you'd like, my depth of cut there. But you can choose peck amounts or percentage of tool diameter. And here I have my first peck at 3/4 of an inch. Then I'm going to reduce that by 50 thou by saying it's going to subtract this 700 from there. So this is going to peck at 50 thou. And I have a minimum peck depth, so when it gets down to the bottom, it'll have a minimum peck. And of course, you can choose extended final peck and a couple other things there as well. And then the last one, we're going to show you, we have peck, and now we have peck full out. So basically peck tap, which is what we've wanted for quite a while. In the past, we've just done macros, custom macros under the macro setting to configure variable pecks and peck tap, things like that. But now it's inside the software, so you don't have to create macros. It's already here, ready to go. And then the last segment, we'll show you this in a second, but let's render this first. So we'll make this transparent. So you can see, slow this down. This is just, of course, drilling. And one thing we do have on is reverse order, basically on the second one and third one. So it's going to drill, change tools, and you can see it's drilling down to our 3/4 depth and then pecking 50 thou at a time till it reaches our total depth. And of course, you can do this as a chip break as well. I just chose fully out. Then for the tapping, our last tool on this segment, you can peck tap, and that's what we're doing right there. So that's a nice new feature. So for the last two operations, let's bring these in. It's going to be, well, the first one I'm going to drill a pilot hole in here with the same tool, tool number 4. And I'm going to go down a 1/2 inch deep and, of course, put in your RPM in that. Now, this is a gun drill, so normally those are very long drills and usually not very big diameter. So if you up the RPM too fast, you're going to snap that tool off. So I'm drilling the pilot hole at 500 RPM and just a slow feed rate just to get a pilot hole in both these. So that's my first operation. The second operation is going to be the same tool, but it's going to be, click on this gun drill. You can see there's a drop down menu. But this one I'm choosing gun drill. So the RPM I want to drill, final drill these is at 3000 RPM and a feed rate of 2 inches. And of course you can change that whatever you want. This is the pilot depth that I did on the previous operation process. And the approach feed is 50 inches a minute, so that means the tool is going to go down at 100 RPM at 50 inches a minute down into the hole. Of course, you can change your depth you want if you don't want to get even close to where you drilled the pilot hole. And then it's going to, of course, go up to 3000 RPM and then, of course, feed down. And I have a final feed rate of 10 and 3000 RPM. Now you can change the program stop after approach. If you want, program the stop at depth, program stop at retract, and stop spindle before exit, which is usually what you want to do. So before you exit out, of course, you want to stop the spindle. Otherwise, when it comes out, you're going to have it turning 3,000 RPM and probably snap your tool again. So if we go to that point, and I'm going to slow this down a bit, and you can see there's my pilot. Then it's going to go back down and drill my gun drill and then back out. So those are some new enhancements in the drilling. And let me just bring these up again. You can see if you didn't wrap it out, that's been there. But on the tap, you can see tap, rigid tap, tap, full out, tap, peck. So you have a number of choices there. And of course, peck, we have most of these in here before, but now you have variable peck and full out as well. Other, gun drill, bore, fine bore, back bore, which we had before, but the new one is, of course, gun drill. And I think this is the same here. Of course, I've already showed you a helix bore on the other processes as well, the enhancement. So that is the first one, extended drill cycles. So enhancement number 10 is Sandvik's prime turning. Now we've been able to do somewhat of prime turning before using the VoluTurn, but this new prime turning module actually refines that a lot better. So before I show you exactly what prime turning does when you program that in Gibbs, I'd like to show you a short video. It's only about a minute long. So as you can see by the video, prime turning is a unique tool path in where you're actually turning backwards on the insert, pulling it instead of normally we've been pushing it for the last 40 years. And it uses two types of inserts. Let's bring up one of the inserts here. And that is what the insert looks like here. It's kind of almost like a 55-degree. It's called a B insert. And then we have this one. This is mainly for finishing. And this is more of a triangle shaped, but this is more for finishing. So if we run the tool path, let's first bring up. So the unique tool path that we do is, of course, you want to pull with the insert. And as you can see, I'm starting below the part here and of course ramping on and cutting up instead of normally where we push the tool to go down for facing. And the second operation is the prime turning here. So let's run the video and we'll show you as well what it's actually doing here. And of course this is the finished tool path here. If I zoom this up here, you can see how the tool is sitting at the angle. And of course we're going to be back facing. And the nice thing about prime turning is you can go very high feed rates. In inch mode, we've been turning a lot of them at 20 thou per rev. and 1/8 of an inch or deeper radial cutting, and that works very well. Of course, just some caveats: you need some good jaws to hold the part. I don't know if I'd use smooth jaws. I would probably use serrated jaws or claw jaws. They hold the part very well in the tests that we have done. Or you could also bring the stud spindle up or tailstock to support it as well. But let's just show you this here. So as you can see, we're going below center line, back facing. Then we're coming up and changing tools and then doing the prime turning. Speed this up a little bit there. Okay. So this time we have kind of a combo tool here with 2 sides on there. And the tool path, you really don't plunge into the part, you always do an arc. And when you're coming off the part, you're doing the same thing. And change tools, and here's our finish tool. And it's nice that it has relief on both sides there, because when you're doing finish turning, if you don't have a lot of clearance between the part, you might get a chip stuck in there and your finish will be very bad. So this is really nice for alleviating that. So let's look at the actual tool path here. So as you can see, we're ramping on and down the cut, and of course ramping off as well when it gets down to here. But the nice thing about it, let's show you the dialog box here. So you have your cut depth. This is in millimeter, of course, in this machine. 3 millimeter depth of cut. You have a lead-in radius, and you have a lead-out feed rate. Of course, you could always put a ramp out as well, or an arc out if you'd like, but mainly this is just going to be straight here. And of course, your finish stock and everything is about the same there. But what I want to show you on here that's unique about prime turning is it's not just ramping in and taking a cut and going. So if I go to my operation here and click on utility markers, you can see it's going to mark the toolpath here. And if we click on the first marker here, you can see the entries at 0.08 millimeters per rev. Then that's our arc in, so our in feed. And then when we get to the actual cut of the part, we're going 0.5 millimeters per rev on the cut. But another nice thing about prime turning in Gibbs is when it gets to the end, if you're going that high of a feed rate, when you get to the end of the part with that high of a feed rate, you have a good chance of chipping the insert or breaking the insert. So right at the end, we can reduce the feed rate. So I have it at 0.1 millimeter coming off the part, and you can see it throughout the whole piece here. So we have our arc in, cut, arc in, cut, and then of course the finish pass. Finish pass, of course, you can decide, turn the markers off, you can decide whether you want to just feed all the way down and across, or you want to feed in and push up. So you have a choice there as well, just like you normally do in Gibbs. And that's the first part of prime turning. And of course, with prime turning, you can do ID work as well. Here we're just drilling, doing a small bore, and then we're doing the prime turning for the roughing. And of course the finish. There's the facing. This is actually nicer than going from the front in a Z- move, because this way the chips evacuate a lot easier. And then our finish pass. So if you haven't tried prime turning, it's a really nice feature to do. Here's one last little step there. So if you check out Sandvik's website, you can see more about prime turning and how to use that with their tools, recommended feed speeds. But the tests we have done, you can decrease your cycle time quite a bit. And this is just our last video on prime turning. Next is enhancement number 11, multifunction insert drill, turn and offset drilling. So with this enhancement, we have a new tool. Here it is again. Let me show you a little better picture of that. And here is the picture of the new tool. As you can see here, you can put in all the different parameters of that tool, the angles and the lead angles, things such as that. But you also have a drilling offset, because when you're, of course, drilling, normally you want to be right on center line, so you can have a separate offset if you would like for drilling and a different offset for turning, or you can use the same one if you'd like. So of course these are type of tools where you can drill and turn with the same tool, and I have just a separate one over here for the outside ones. But in order to do that, if we bring up our OpSim, and we'll get to this point just to get up to there, and we'll slow it down. So the next stop is we're just going to take that tool and drill with it. And then of course we're going to do the offset turning, which is using, of course, the same tool. And our finish cut there. And just some outside drilling with the same tool. You can see the shape of the tool. Let me bring the picture over there on that. And of course this is what the tool will look like in the rendering. Most of them have, of course, a little taper here as well on the shank. So you can describe the tool a lot better than you could before using just a boring bar and using that as the drill. So this is a nice enhancement. So the drilling dialog box is a little bit different this time. We already showed you these up here, but over on here on this operation number 4, we just want to drill right on the center line. So you can use the tool center if you want. You can offset it if you'd like, and the diameter you want to cut. So this is something new in this area here. So you can use the same tool to drill and then same tool to do the ID turning. So that's enhancement number 11, multifunction insert, drill, and turn. So in our last enhancement, it's called lathe drilling with counter-rotating live tools. So this is pretty straightforward here. A lot of times if you want to drill straighter holes in an MTM machine with live tooling, you want to have the spindle rotating at the same time as the live tool is rotating, and it'll go opposite of what the spindle turning will do, and you'll get straighter holes and bores with that. So let's bring up the operation here. So in the drilling dialog box now, you have the standard RPM. This would be for your spindle, and your feed rate, of course, that you would like to do. But over here on the right, you have a checkbox that says tool spindle on. So this would be your tool speed for your live tool. So basically you would add the two up, 1,000 plus 600. You'd basically be turning a 1,600 RPM tool, cutting your part. So you have your feed in, everything else on here. So it's a pretty straightforward here. The rendering is just going to show you going in and out, but it'll put the code in. I know on most FANUC controls it's like an M90, M90, and for the subspindle M290, and M91 to turn off, M291 to turn off. But I'm sure other machines use different M codes as well to do that. But that's counter-rotating tools. You'll find if you're doing that, your holes will be much straighter when you're drilling, especially if you want to drill and then ream later. This will make a nice, a lot straighter holes in your parts. So these are enhancements 9 through 12, and we have more to come. Thank you for watching.